can see there's a nut, double nut here and a double nut at there, 3/8 inch rod. This is a 1.5 inch PVC cap. This should really be sealed, so you want to put either some silicone caulking there or here or hot glue or whatever, just so you don't have to worry about it leaking. So first thing we'll put together is the float. This is fairly easy. The float's done. Now we'll assemble the tanks. Okay. That's one tank. And the top one, this is the pressure tank, the actual breathing pipe. This one goes down here. This is for the exhalation tank. So the float will be fitting in there. Now this is a 3/4 inch ball valve. We're going to take some 1.5 inch PVC pipe. And one of these sides, let's see which one. This side will get an elbow. I'm going to move them like this so they're closer to what I have in the drawing. This one will get a T. Now we may need to put the valve in between here. So we need a couple of pieces of 1.5 inch, I'm sorry, 1 inch PVC. This is a 1 inch ball valve. And we're going to walk that off to the side, like so. Okay, we need to make our sight tube. This is a 1 inch to 1/2 inch. Really should have some tape around this, but it's very low pressure, so it should be okay. Again, 1 inch. This is roughly 2 feet of 3/8 inch hose. This is right off of what you will read the air pressure in the lungs. It allows you to know how much air is being displaced in this tank, and we can read that off the height of the water column. Okay. Now, we need to have the ventilator set up at the top. Get the pieces here. Okay. Oops, wrong one here. Let's do it with this one. Okay. This is 1 inch to 1/2 inch. This is the air input, and this can be compressed air of any type, and it can also be mixed with oxygen if necessary. This should be a 1 inch to 3/8 inch fitting, but I just used some epoxy putty because they didn't have exactly what I needed here. So this is where the air line connects to. Let's see what else we got. Not a lot. Okay, this is a 5-foot washing machine hose that can go to the tube into the patient. Now this is kind of important because this should not be flat. This should be offset somewhere. So when this rod comes up, it'll clear it. Clear it like that. Not too much. You want this rod to be able to come up and operate this valve right here. Good. All right. Well, we always got leftover pieces. That's okay. And then just tape these across for a little structural stability. Let's do this. Let me get something here to take the pressure off of this. That's okay. That's it. So that is your homemade ventilator in about 20 minutes. So the way it operates is pressurized air or oxygen comes into the tube here. This is a quick disconnect tube. And then you vary the amount of airflow by this ball valve. So you want to just, by turning this on, you're increasing the number of breaths per minute. So it can be very quite wide. Now what happens is, this will be a valve up here. The air moves down here into the patient and also into this tube that's filled with water. As the lungs expand, are pressurized, it moves this column of water down, and then this column of water up, which can be read by the sight tube, so you know how much the lungs have inflated. If this moves 10 inches down, that's about 500 cc, which is a pretty good rate. And then as soon as it hits whatever we want it to, we've got little, I'll show you these later, but these are 1/4 inch or 1/8 inch nuts, hex nuts. It'll move this float up, and when the float comes high enough, whatever we set it for, it'll trip this magnetic valve. It's a toggle valve. So what it'll do is it'll open, and then once it's open, it stays open until the rod closes it. So well, let's do it like this. It will open the valve. This will all be exposed to the atmosphere. The lung will deflate. It will deflate at a rate that is governed by this ball valve here. So if this is fully open, then that pressure will be very quick. So this will, and the float will go down. Now, by the time the float goes down is when the process will repeat, because then this upper hex nut hits the valve, magnetic valve, and it stays shut now no matter what, till it's pushed up. So between these set of hex valves on this float is what's going to determine, so the flow of water is going to determine how fast that float comes down and starts the process again. So ask a physicist, and I think they'll tell you this setup will work. And Hopefully it's helpful. Let me say a couple of things about the design. So what you don't see here is the valve up on top. But you can think of this as the lid of a tea kettle. And you know, if you push the tea kettle button open, it'll spring open, and then you let it go and it springs back. Well, imagine that there was a magnet up here. So when the tea kettle opened, it got stuck on the magnet. When the rod came back down, the weight of it pulled the lid shut. And as soon as it broke the magnet attraction, it would snap back shut again. So that's what's happening here by the placement of two hex nuts that we're going to add. So I didn't want to wait to actually build that portion of it because that's going to take me overnight. And I know that a lot of people need this now. So as you can see, I've disconnected the hose because I had a bag on it and it has a leak in it. So I think I can explain it just as well. So the human lung holds about roughly 500 cc's of oxygen. Anywhere from, I think, 250 to 600, double check that. 600 cc's is okay, but more important than the volume even is the pressure. And this is one of the reasons that the COVID-19 is so deadly, is that people go into respiratory distress and the lungs become harder to push open. And if you go over 30 centimeters of pressure, 30 centimeters of water, which is just like 30 centimeters of mercury, except it's a much lighter material that we can measure. So if it goes over that pressure, it will do lung damage if it plateaus over 30 centimeters. 35 it can peak at, but then it should immediately drop down. So you have to make sure that it's not going to do that and still provide enough volume. So that's where this comes in handy. So the lid slams down, the air comes out here, it's pressurized as it enters the patient's lungs. So it starts to be a back flow on her, a back pressure. And the pressure builds up, pushes this tube down, and you'll see the column moving here. Now you really won't be able to see probably the column, but you know, you can use colored water here too if it makes it easier, it doesn't matter. But what you will see is this rod starting to move up in the same manner that the water level does. So when that column moves down 10 inches, this column has moved up 25 centimeters, same thing, 10 inches. And at that point, it will hit the nut to open the lid. The water will drain back in and become equalized based on the bottom valve there. So you can slow that down so the patient has time between breaths. As the water goes down, it eventually comes to that second nut and snaps the lid back down, and it starts to repeat the cycle. Now, because I don't have any pressure here, I'm going to have to just hold my hand over it and then operate this, but I think you'll see how it works. So I start the pressure flow, and that's a slow rate, that's a fast rate, and the faster the rate, the faster the breaths per minute will be. So, as soon as the lungs start building up pressure, when this valve is closed, you can see the rod rise. As soon as that snaps open, the pressure falls off, the lungs collapse. So, the inhalation time is dependent just on the airflow. The exhalation time is dependent on that valve. If you start closing that valve down, then it takes longer for the rod to sink and the valve to close. So you never want to have this level raised more than 30 centimeters. But At 30 centimeters, depending on the patient's lung capacity, that will only be a certain amount of pressure with this setup. So if you want to vary the ratio between the pressure and the volume, you can do so. So you can fiddle around with it, but that's the way you can change the ratio, is just make the difference in the size of these tubes bigger or smaller, and it'll do the equivalent of that. So tomorrow I'll put the rest on, and I hope everybody's doing well. Well, one last thing. If you think this is it will work, and if you're a physicist or a biologist, please get this to the right people. It's not an easy thing to do. So I think this can save an awful lot of lives, but there's no way to, call up the president or the head of the CDC and say, hey, guess what? So hopefully you guys can do it for me. Thanks.